Hey guys, and welcome to a little physics tidbit on scale. So here you can see we've got quite an interesting image going on. You may be wondering what exactly this is. Well, that is a single grain of salt, and the boxes in the background, each one of those boxes is 0.1 millimeters by 0.1 millimeters. So using that information, we can see that this grain of salt is about 0.8 millimeters by 0.5 millimeters, and the height is roughly 0.3 millimeters. So, using this information, we can do some calculations and actually figure out how many molecules are inside of this grain of salt. But before we do that, let's zoom out a little bit here. Now that we've zoomed out quite a bit, you can see this yellow object on the left of the screen there. That is actually the tip of a wooden toothpick. So this grain of salt is quite small. Let's see if I can get these little extra grains out of the way here. And this one's kind of stuck to it. I can't really lift up. There you have it, a single grain of salt. Let's do some quick calculations. And so, to figure out the number of molecules in this grain of salt, there are a number of different methods you could follow. But the method I follow is utilizing the knowledge of the weight of a single salt molecule. So, we know that our grain of salt is 0.8 millimeters by 0.5 millimeters by 0.3 millimeters. We also know the density of salt, 2.16 grams per cubic centimeter. And as I said, we know the weight of a salt molecule, 9.7 times 10 to the negative 23rd grams. So the volume of our grain of salt then is 1.2 times 10 to the negative 4th cubic centimeters. So therefore the mass of our grain of salt here, it would be the density times the volume that we found here. And we get 0.0002592 grams. Then, by dividing this by the weight of a single salt molecule, we can get the number of total salt molecules in this volume. So, that number comes out to be 2.67 times 10 to the 18th molecules of salt, which is a huge number. For comparison, this number is about 133,500 times as many red blood cells in our body, which is, I believe, 2 times 10 to the 13th. And taking it one step further to get an even better sense of scale, if you take a single red blood cell, its volume is about 9.9 times 10 to the negative 11th cubic centimeters. And with the information that there's about 2 times 10 to the 13th red blood cells in the body, if you were to squish all the red blood cells together individually, not including plasma or anything else, this would take up about 1,982 cubic centimeters, or 1.982 liters of space.